This next question is right up Steve's alley. You're going to have to explain the question to us. Wade says this: in the beginning, isn't there the possibility of beginning as a white hole rather than a black hole?
Oh, okay.
So what's a white hole? I know what a black hole is.
Okay, well, let me explain a black hole first.
Okay.
And so the premise of Wade's question there is that when you're starting with the beginning of the universe, it looks like the universe is spreading out, and so that's called the expansion of the universe. And the way we know that is because when we look at galaxies, when we look at distant light from stars and galaxies and such, that light is shifted towards the red, and that's what's called a redshift. And not to make this a big old science lesson, but basically, when you're looking at elements in starlight, so for example, lots of hydrogen in the light that comes from the sun, and so hydrogen has a certain spectral image, and so basically, when you take the spectrum and you graph it out, when you see hydrogen, there's going to be a spike along the spectrum, along the line of light that's coming out of there, and so you can tell that that's hydrogen. Well, when you look at hydrogen from our sun, it's right where hydrogen should be on the spectrum. But when you look for light, look at light that comes from a long ways away, that spike is shifted towards the infrared, and so that's called a redshift. And the reason that it's like that is because that galaxy is moving away from us, and so basically it makes the light shift. And the best way to explain this is by using the shift in tone when you have something coming towards you. So if you stand on a train, stand by a train track, and you have a train coming by you. Well, even with cars, you have a car coming by you. What you'll hear is, and what you're hearing is the shift of the sound. As the sound is coming towards you, it's being compressed, and as the car is moving away from you, that sound is the sound waves are spreading out, and so you hear the difference in sound. It doesn't sound the same. Well, light does exactly the same thing. So again, when we look at distant light, it's moving away from us, and the further it gets away from us, the faster it's moving, and so that's called the redshift.
Okay, one question.
Yeah.
The difference between your analogy on sound and light is light is a constant speed, right?
Light, yes, light is at a constant speed, but when you have something moving away from us, the light will shift just like sound waves shift.
Really?
Yeah.
Okay, because I was thinking
it compresses. It compresses or it and it's just the wavelength.
Okay.
It's not the speed.
So the wavelength changes on distance, even though speed's the same.
Right. So when you're talking about sound waves, the speed of the sound waves is exactly the same. Right. So the speed of sound didn't change because the car was coming towards you or going away from you. What happened was it's still moving towards you at that same speed. It's just that the wavelengths are being compressed because of the speed of the car.
And so when you're talking about like the sonic boom where it reaches past the sound barrier, that's a compression
that's something that's different altogether.
Okay, that's what's confusing me then.
Right. And so when you're looking at the speed of sound versus sight, what you're doing is you're comparing the speed of sound to the speed of light. And so when you see a jet way up in the sky and you listen for it, well, it sounds like it's back here, but if you're going to find it, it's way ahead of that. And so there's that whole aspect of it, and that's the speed of light versus the speed of sound. And with the sonic boom, what's happening is you're pushing the atmosphere against the atmosphere, and it's making basically kind of an explosion.
Okay.
That's what a sonic boom is.
Okay, so it's the atmosphere separated, not it's
Right.
kind of different than the speed
Yeah.
of sound. Okay.
Yeah. Yeah.
All right, clear as mud.
Okay. So anyway, again, that whole thing with light, the reason I'm telling you that is because the universe looks like it's expanding. Okay. So if it's expanding, you go back in time, you would contract it. And so the whole universe would be in one spot. And if you have the whole universe in one spot, you have the biggest black hole there could ever be. Because a black hole is basically the mass of a large star that's been gravitationally compressed to within a certain limit, so that the gravity is so radical that light can't escape from it. So light falls into it, but it can't get out. That's why they call it a black hole. Well, if you take all the mass in the universe and you stick it in one spot, you got the biggest black hole ever. Okay, but that's the mistake in Wade's question here, because in the Big Bang Theory, you're not talking about putting all the mass of the universe in one spot. What you're talking about is shrinking the whole universe to a point. And there's a difference between, and when you talk about the universe, you're talking about space. So you're shrinking space to a point. All the mass is contained in the space, but the space itself is there also. And so it circumvents the physics that would make it a black hole. This is how they get away from a black hole in the universe. And part of the reason for that is because they make the universe unbounded. And sorry for that, but basically the illustration for an unbounded universe is like taking a balloon, and on the outside of a balloon you put a bunch of dots, and then you blow the balloon up. And as those dots, as the balloon blows up, all those dots are moving away from each other. Okay, and if you pick one dot, within sight of that one dot, it's going to look like all the dots are moving away from you. Okay, and so that's taken basically a three-dimensional object, a balloon, and putting it on a two-dimensional plane, so to speak, and spreading that whole thing out. A better illustration would be, the reason that they do it with a balloon is because there's no edge to a balloon, and that's what they're trying to get away from. And so if you have a universe that doesn't have a boundary, then you get away from the black hole thing. Okay, the thing that Wade is talking about here is there is a cosmology that's called a white hole cosmology, where you don't have an unbounded universe, you have a bounded universe, which means that there's an edge to the universe. Okay, so in the Big Bang cosmology right now, most astronomers are into, or astrophysicists are into, you could literally look that direction, and if you could look far enough, you could see the back of your head. That's how that cosmology works.
And what do they term that as?
That's unbounded universe.
That's an unbounded.
Right. So you're looking around the balloon, and you're seeing the back of your head. Okay. And you can't do that, but that's the idea behind it. Okay, so that's an unbounded universe. If you put a boundary on the universe, then if you put all the stuff in the universe together in one space, then you do have a black hole. And so what this cosmologist did, he's a creationist, was he put all the universe in one place, including the space, but made it a bounded universe. And then he talked about it's called the gravitational constant. If you change the gravitational constant, then what ends up happening is the universe has to spread out, and the center of the universe becomes a white hole. And so a white hole is exactly the opposite of a black hole. What you have is a situation where all the mass in a white hole is being spewed out, and light can't get into it. You can't see the outside. In a black hole, you would be able to see the outside because the light's coming in. It's going to get bent and tweaked and all that stuff, but it's still coming in. In a white hole, you wouldn't be able to see light from the outside because everything's being pushed out. Okay, and the idea behind that, and the reason that this cosmologist went there, is because if you had the Earth in the center of the universe, and you had a bounded universe, which would make mass together make a black hole, and you change the gravitational constant, you just tweaked it a little bit. If God did that, then you would have the universe spreading out. And what would take place is when the Earth got to what's called the event horizon, and that's where now you can see things. So in a white hole, you wouldn't be able to see out, and so it would you wouldn't see the rest of the universe until you got to the event horizon, and then now the light can reach you. Well, when you get to the event horizon of a black hole, the physics is such that time stops for you. And so you could literally see galaxies being formed out on the edge of the universe in a day.
This is like interstellar stuff.
Right. It's like interstellar stuff. And so the idea behind that is bounded universe. God tweaks the gravitational constant. The universe begins expanding. The Earth is somewhere towards the center of the universe. It reaches the event horizon on the fourth day, and literally you would see the stars popping into the heavens. You would see them created on the fourth day. And you could have distant galaxies be billions of years older than the Earth, because time is going, basically, it's like a clock at the event horizon would look like it's barely moving, like a normal clock, while if you looked at a clock out at the edge of the universe, it would be spinning so fast that you wouldn't be able to see it move. That's how quickly time would be going. And it has to do with relativity and that kind of stuff. So, yeah, that's one of the cosmologies, and it's very interesting, and it's one that has a lot to recommend itself. I kind of like that whole thing, and so there.
Okay, one last thing, and then we'll move on.
Okay.
I get, like, when you're talking about stars, what'd you say, the fourth day or whatever, that the principles, the methods of the universe are there, and so you have that going on. But in the beginning, when he's doing the first creation, it doesn't necessarily have to happen the black hole way, right? Because he's speaking it into existence, and it's like there, right? You can.
Yeah, well, one of the things that one of the reasons that this is an issue is because we're not just dealing with what the Bible says. We're dealing with what we see in the creation, and so when you're looking at what we see in the creation, you have a situation where again it looks like the universe is expanding, and so if it's expanding, it was contracting. It expanded from a point,
right,
at some point back in the past. And what happens with the white hole cosmology is it's a way to explain distant starlight and distant galaxies. Basically, if you had a white hole cosmology, when the Earth gets to that event horizon that I was talking about, there is no time being spent on Earth, while at the very same time in other parts of the galaxy you could have billions of years.
So it's a way to explain the ages.
Yeah, it's a way to explain distant starlight is the deal.
Okay.
And so, different ways to explain distant. I don't want to get into a whole thing on this because this is such a big subject. But the way that distant starlight has been explained, one explanation is that God created the universe all on the same day, and that the starlight, that God created the starlight in between these distant galaxies and us, and that would be problematic because you've got some issues there, because it looks like time is passing out there, and so it would be, all the starlight in between would be fake. And that's kind of weird, and so that's one issue that you have with that. The thing about the white hole cosmology is that you have time in the distant universe for this light to get to us at the speed of light. You have time for it to get to us while there is no time passing on the Earth. And so that's that whole thing with getting to the event horizon and that kind of stuff. So that's kind of cool. And so that would mean on the fourth day we got to the event horizon, we could see the universe and we could literally see God's creation coming to pass in real time in a day on the Earth. And we know that the universe is like this. We know that can happen according to the physics. And so that's kind of a cool thing. Another cosmology has to do with the speed of light. And this is way more technical, but we don't know the one-way speed of light. We know the two-way speed of light. And so the reason I can measure light is the speed of light is because I can take and shoot a beam of light in a certain direction, bounce it off of something, and when it comes back, I can measure its speed. So I have to measure it going and coming, and so there's a certain amount of time that this takes place, and then what I do is I take that amount of time and the distance involved, and that's where you get the speed of light. Okay. Well.
Okay, I have maybe a dumb question.
Okay.
Don't they have a machine that can have light start, like a flashlight, and then something to measure it on this side without having to have it bounce back?
Yes, you can do that. The problem is, put your hands back up. The problem is you got a clock here, and you'd have to have a clock here. And once you move the clock, they're not synchronized anymore.
So we're talking about minuscule things, but in the context of the mass of the universe and all that stuff, it can be big.
Yeah. So that's the deal with relativity.
Right.
Time passes differently in different places, and so you can if you have a clock in one place, and you have two clocks in one place, and you synchronize those two clocks, as soon as you move one of them, you've changed time.
Yep.
Because it's moving.
Yeah.
And so time changes based on where you are or how fast you're moving. So it doesn't matter how slow it moved, you change, that clock is different. Right. It's no longer synchronous with the first one. And so there's no way to measure the one-way speed of light.
Gotcha.
And so, but again, when you look at this, there's a deal with this. When you're talking about relativity, that the speed of light doesn't have to be constant in both directions. So you could have the speed of light being one speed going out and another speed coming in. And one cosmology states that the speed of light coming towards us is infinite, while the speed of light going away from us is something that can be clocked and takes time. And that works with relativity.
Wow.
That's really weird. Which would mean that when you're looking at what we would call the edge of the universe, the things that you're seeing on the edge of the universe are taking place in real time as we see them.
That's a mind trip.
Yeah, that's a mind trip.
It's like quantum mechanic crazy stuff.
Yeah. There's a lot of crazy stuff. So, bunch of interesting things, but yeah, that's Wade's talking about the white hole cosmology.